Propositional logic and set theory. Dear, in this part we will see exercise and propositional logic and set theory on the first exercise. Dear, don't forget to subscribe, like, comment, share in order to give different questions from exercise or the definitions from the handout or explanations of the example and exams made or final exams from different universities. Now let us start from exercise. Exercise 1 says that which of the following sentences are propositions for those that are indicate the truth value. That means from the given statement or sentence which are propositions, after you have selected, then you should have to indicate the truth value. A. 123 is a prime number. This is what a proposition because 123 is a prime number since it has what? Only two factors, 1 and itself. So that this is a proposition with truth value 2. B. 0 is an even number. This is what? A proposition which has truth value 2 because an even number is a number given an integer which is called an even if it is divisible by 2, so that this is 0 is divisible by 2, so 0 is an even number. So it is what? A proposition with truth value true. C. X squared minus 4 is equal to 0. This is a proposition not. This is not proposition because it's difficult to say or to determine the truth value or to determine this truth value whether true or false. So that this is not a proposition. This is what's called? This is an open proposition. That means if it is the values of x are replaced by some arbitrary number, then it becomes or has truth value true or false, then it becomes a proposition. So for the time being, x squared minus 4 is equal to 0 is not a proposition. D. Multiply 5x plus 2 by 3. This is not propositions because this is what? Common sentence. B. What's an impossible question? This is what's not a proposition. Another question from exercise is state the negation of each of the following statements. Square root of 2 is a rational number. So how we can set the negation of this statement? Square root of 2 is a rational number. Therefore, the negation of this square root of 2 is a rational number becomes square root of 2 is not rational number. Or in other ways, square root of 2 is irrational number. B. 0 is not a negative integer. The negation of this statement becomes what? 0 is a negative integer. C. 11 is a prime, not 11, 111 or 11 is a prime number. That means 111 is a prime number is a given statement, so its negation becomes 111 is not a prime number. Another exercise said that let's given proposition say P. P is given as 15 is an odd number. Another proposition say Q. 21 is a prime number. So start each of the following in words and determine the truth value of each. So what is P or Q? P or Q can be stated using in words like this. 15 is an odd number or 21 is a prime number. What's the truth value for this? Since 15 is an odd number, this is what? What is true, isn't it? Because 15 is not divisible by 2. So that 15 is, or P is what? True. Q, 21 is a prime number. Is true or false? This is what? Which is false, because 21 is not prime. Rather than 21 is what? Composite number. So 21 is not prime number. As a result, P has truth value which is true. Q has truth value which is false. Therefore, P or Q is what? Which is true, or false is which is true. Another P in the Q. P in the Q can be written as in words 15 is an odd number and 21 is a prime number from the above. Since 15 is an odd number which is true, 21 is prime number which is false, therefore true and false. This becomes what? Which is false. Negation P or Q. Since from the above P, 15 is an odd number, so its negation becomes 15 is not odd number or 15 is even number. So negation P or Q can be written as 15 is not an odd number or 21 is a prime number. What is the truth value for this? Since P is from the above, P is true, then its negation of P becomes which is false. Therefore, we have that false or false. So false or false is which is false. P in the Q. From the above we have P and the Q, so we can write in words. Sorry, notes. This is not Q. I think this is negation P in the negation Q. P in the negation Q can be written as there. Don't forget, write this. Here we have negation. So P in the negation Q. P in the negation Q can be written as 15 is an odd number and 21 is not a prime number. From the above, since Q is 21 is a prime number, negation Q, please, here we have negation Q. Otherwise, this is the same as with A. So with B, so that P in the negation Q becomes, since P is true, 15 is odd number, which is true, and the negation Q, which is 21 is not prime number, which is true. So that true and the true becomes true. Therefore, P in the negation Q becomes true. E. P implies Q. P implies Q is the same as P implies Q can be written as if 15 is an odd number, then 21 is a prime number. Or in other ways, we can write this words like this. 15 is an odd number implies 21 is prime number. So what's the truth value? It is from the above, P is true and Q is false. So that P implies Q. That means true implies false, which is false. Therefore, P implies Q becomes false. F. Q implies P. Q implies P is written as if 21 is a prime number, then 15 is an odd number. But from the above Q, that means 21 is prime number which is false, and 15 is an odd number which is true. Therefore, we have here false implies true. False implies true is what? Using implication error. False implies true is which is true. So Q implies P is true. Negation P implies negation Q. From the above, we have P and the Q. P is 15, an odd number, so negation P becomes 15, it's not odd number. Q, 21 is prime number. Negation Q is what? 21 is not prime number. So negation P implies negation Q is 15 is not odd number, then 21 is not prime number. From the above, P is true, so negation P becomes false. Implies negation Q. Negation Q is, since Q is true, so negation Q is false. So we have false implies true. This is which is the same as or has truth value which is true, because false implies true is always which is false. True. So negation P implies negation Q is true. Negation Q implies negation P. Negation Q implies negation P can be written as if 21 is an odd. If 21 is a prime number, then 51 is not an odd number. Therefore, if 21 is not prime number, then 15 is not odd number. is written of, or we can write this is the word form for negation. Q implies negation present the truth value from the above. The Q is Q here is which is false. The negation Q is which is true, and the negation P. Negation P is, since P is true, then negation P is false. Therefore, here we have the same as which is negation Q implies negation Q implies negation P is which is the same as true implies false. So that true implies false is which is false. Therefore, negation Q implies negation P is which is false. Now there is complete the following truth table. Now here we have given proposition PQ, P as truth value true, true, false, false, Q, true, false, true, false. So we need to find negation Q and the P and the Q. So as solutions for the given propositions P and the Q with P with true, true, false, false, and the Q with true, false, true, false. So therefore negation Q becomes, if Q is true, negation Q is false by the definitions of negation. So negation Q here becomes which is false, negation Q becomes here which is true, false, true. And P in the negation Q is the same as P is here, and the negation Q is therefore P in the negation Q is always true if P is true and negation Q is true. So we can search the truth value for which P has true and negation Q is true, then they becomes true, otherwise all are false. Therefore here true, true, which is generally P in the negation Q is the same as true and false, which is false, true and true, true, false and false, false, false and true, which is false. Thanks for watching, and we will proceed to the next parts